Alright, welcome back. As I said in the previous video, we are going to look at solution to first order linear differential equations. In fact, all that we have been doing for the previous techniques is all about finding the general solution. It's all about finding the general solution. Alright, now with the first order linear differential equation, we are going to look at the solution to it in two phases. So this is what we are going to look at it right now is the method 1. And to start with it, there is a need for us to go through the whole process, generally before we come on to solve questions. In fact, most students don't like with proofs and all that, but please, it sometimes helps you a lot because it generates the same idea in solving when you have a question. Alright, so now that you know how to identify what a homogeneous equation is and what non-homogeneous equation is, then we can go through this successfully. Alright. So firstly, given that dy dx plus that is equal to p of x. Let's name this equation 1. Now, you know from our previous video that when you have an equation, a differential equation in this form, it means that we can get two forms from this equation. We can get two forms from this equation. And the first one is when P of x is equal to 0, then we can have dy dx plus that is equal to 0. So we established, let me name this equation 2. We established in our previous video that this gives a non-homogeneous differential equation, and this is a homogeneous. This is a homogeneous differential equation. So we have established that already. So non-homogeneous equation, and this is a homogeneous. This is a homogeneous. So we are going to name this equation 2 and equation 1 and equation 2. We are going to lay emphasis on it when going through. So make sure you don't forget that. Now, I would like to play what we have just. Okay, let me come to this side. Now, let me play this. So, finish writing it. Now, we are going to prove to start from this. We are going to start from this, alright? So, from dy dx plus p of x is equal to 0. We can make dy dx a subject, and we get this p of x multiplying the y. And you can see that we can make this a problem for us to take the integration. So, to make this a problem, we write dy dx over y being equal to p of x, then the dx. After that, then we take the integral of both sides, here as respect to y, here as respect to s, and we end up getting ln y here to be equal to, here we leave it in that form, which is an unknown function. Alright, but we know that right after every integration we add plus c, which is the same as ln c. Very good. So we can simplify this. We can simplify this to get ln y minus. Make sure you follow me well. Very good. And with this, we can get ln. Alright. Now, for us to get y over c, we can take the natural log on both sides. And when you take the natural log of both sides, you get y over c. Very good. Very good. And here we can make y the subject, so we get y to be equal to c e raised to the power negative p of x. Alright. So now what we have, this is the general solution to the non-homogeneous differential equation. So that means that when you are given, watch, when you are given the general form, which is, when you have a function in this form, you can, this is not homogeneous, but you can bring the homogeneous out. That is by equating it to 0. Not just by equating it to 0, but first knowing that it's in this form, then equate it to 0. Then you find the general solution. So this becomes the general solution for the homogeneous part. I want to take my time to take you through this. And it's the same as solving the question. This is the general. And since that is the general solution for the homogeneous part, we have to make it specific. So we write y subscript h, that is the homogeneous, to be equal to c e raised to the power negative integral of p of s dx. Very good. So we are going to name this. Don't forget that we have already established equation 1, equation 2. So this becomes equation 3. Alright. Then, that is that. So this becomes equation 3. So, our only problem now is to go and find this C of S. Now, I'm coming. After getting it in this form, and you have to write it in the form of y subscript h, we have to do something first. I'm going to do that. We have to write C of A because this constant is going to be in terms of X. This constant is going to be in terms of X. So let me name that equation 4 because this is not the same as this. So y subscript h is equal to the constant in terms of x raised to that. Very good. Now, our only problem now is to go and find this C of s. So that is what we are going to find. And how are we going to go about it? Let's move on. So we are going to start from the equation 1. Let's look at it from equation 1. Okay, I would like to clean the board and come back again. Alright, so we have already established that the homogeneous equation, the general equation is going to be in terms of, is going to be in this form. Alright, it's going to be in this form. Very good. And we name that equation 4. And we name that equation 4. Alright. So, our only problem is to find this C of S. So for us to go and find that, let's pick it from equation 4. Rather, not equation 1. Let's pick it from equation 4. So from equation 4, when you differentiate it, you are going to get dy dx to be equal to, now this is a constant which is a function in terms of x, and the whole of this is also another function. So to differentiate the right hand side, we need to apply a product rule. So product rule says that differentiate this, then leave this. Plus, you see what you see that we are doing product rule. Differentiate this, leave this. Now, we leave what we differentiated here. We leave that. Then we differentiate this. Now watch. If you are differentiating this, let me locate it here. If you are differentiating this, you know that when you are differentiating a natural or an exponential function, if you are differentiating exponential function, the whole of that will repeat, but before that, everything on top here will multiply the whole of this. Alright? That is, let's say we have this. Okay? So this will be 2 e raised to the power 2s. That is what is going to be. And if there is a function here, you differentiate that function. So let's give it to you here. So we are going to get this. The whole of this will step down. The whole of this function. Alright. Then we have this. Now, I'm sure someone is saying that, why are we not bringing the integral sign here. The reason is that it's like this. E raised to the power 2s. Y is equal to e raised to the power 2s. Let me take it to calculus more. Y is equal to e raised to the power 2s. You repeat everything, then you differentiate whatever is here. So when you differentiate the 2s, you are going to get 2. That's why it will be 2 e raised to the power 2s. Now, having e raised to the power negative s, I want to take my time to let you understand how. You are going to repeat everything here with a date, but need to differentiate everything there, and that is negative integral of p of s dx. Now don't forget that if integration can undo differentiation, then differentiation too can undo integration. So when this differentiation undo, so this differentiation here is going to undo the integral. So the differentiation undo the integral for us to get this up. So we have the function of c in terms of s multiplying negative p of s, because when it undo that, that is what you're going to get, and the ds2 will go. All right. So we get this multiplying this, and the whole of this, that is this, will repeat, and this will be left with only negative p of s. I hope it's clear now. Thank you. Alright, so since it's clear, we continue from here that dy dx is going to be equal to c prime of s e raised to power negative p of s ds. Now the negative here will affect this minus c of s p of s integral of, let me bring it out. Hope I have cleared the air that the integration sign will come. Alright, very good. So from what we have now this is a simplified form and we can't do anything about it. So we name this equation 5. Alright. So now we have y dx to be equal to this, which is the equation 5. So we are now going to take it from, so now, from the general equation for the first order. That is the non-homogeneous part. So now, from the, we are quoting from the non-homogeneous part. And you know that this is the non-homogeneous part. Very good. So now, from the non-homogeneous part, we are going to do substitution. And the substitution that we are going to do is very simple. We know that the dy dx here, we know that the dy dx we have here is the whole of this. Yes, we are going to do substitution of the whole of this. So we are going to replace this dy dx by the whole of this. We are not going to do anything to this p of s, but we also know the y. We also know the y. And the y is, that is the equation. I'm coming. The y will be the equation 4. The y is going to be the equation 4. So we know that of y already. We know that of y already. In fact, alright, let's move on. So we know that of y already. And also, what will be left? That is all. So we are going to do the substitution. But please, I would like to correct myself on something that I did previously. Sorry for that. Now, don't forget that after getting, go back, after getting this, then we said that since this is a general solution for the homogeneous part, we are going to make it h of y subscript h is equal to c y subscript h. Very good. Now, I think I made you make it in terms of x. Please, it's supposed not to be in terms of x. This is supposed not to be in terms of x. The y subscript h should be equal to c e raised to the power negative integral of p of x dx. This is supposed to be the solution for the homogeneous part. And don't make it equation that or that. Just leave it like that. So this was the solution for the homogeneous part. Then after that, you come and rewrite it. You come and rewrite it by bringing. You come and rewrite it by bringing this. Because and now it's no more going to be subscript h, it's going to be subscript p. Because if you know that for the homogeneous part, then we have to know that for the subscript p, and that is the particular solution. Please, sorry for that. And this is what you're going to name it equation 4. So this equation 4 is supposed to be subscript p. And then you go back to your notes and do that correction for me. Alright, so with this, don't name it, but name this equation 4, and that is what we have here. Alright. Thanks for the correction. So the problem was that we have to find this c of x for us to get the particular solution. So that is why we pick this to differentiate it. So by product 2, then we get equation 5. So now we take it from the non-homogeneous part because we are looking for the general solution for the non-homogeneous part. Alright, but with that one, the y subscript h means the homogeneous part, and this one means the non-homogeneous part. Alright, but we can't make it, and it's supposed to be p. And now we get the particular solution. So after that, we can get the whole of the non-homogeneous part because it's inside the non-homogeneous equation. It's inside the non-homogeneous equation. Now we can get the homogeneous equation. Alright. So what we're going to do here is that I'm going to clean the board right now. We are going to write the whole of this to replace the divide dx plus the p of x multiplying the y. Now this will maintain, but this will not maintain. This y is going to be equal to the y subscript p. This y is going to be equal to the y subscript p, but this will maintain. So this will not maintain. This will not maintain. Don't forget that this function is what we differentiated through product 2 to get the divide dx. I think I have explained a lot. Alright. So I don't want to rewrite it again. So we are doing a substitution. I need more space. Alright, since we have cleaned that part, we are doing a substitution to divide dx plus p of x y is equal to p term of x. So the divide dx is those terms, and that is You can bring this one first or that one first. It doesn't matter. Because this P of S is coming from here, and then Y is C of S multiplying this. All we can see where it's coming from. Very good. But why is it? Oh, we are still writing there. We are still writing there. Dy dx. We haven't gone to that part. We are still writing the dy dx. Alright. So we are now going to write this part. So the whole of this is the dy dx. Alright, that ends with that part. So the whole of this is the dy dx plus. Then we come to this part. We have P of S multiplying the y. And we know the y to be then we equate that to Q of S. Q of S. You can see that the whole of this is going to cancel out the whole of this. The whole of this is going to cancel the whole of this. Oh. That place is supposed to be C in terms of X. That place is supposed to be C in terms of X. Don't forget that we are doing the substitution of y is equal to C in terms of X, which is yp. Then e raised to 1 negative P of S dx. So that is that. So this will clear up this, and we are going to get C prime of X, and we are going to get C prime of S e raised to the power negative P of S dx plus P of S. Oh, we are clear up that part. So it's just the whole of this equating to Q of S. Very good. So we said previously that our problem is finding this C of S to do the substitution, but for us to get the solution for the particular solution. So here we make C prime the subject. So we get P of S over e raised to the power negative. Alright. And by dividing, we get this. So for us to get, it's not C prime of S that we are looking for, but rather C of S. So we integrate both sides as respect to X. Alright? And when you integrate, okay. And when you integrate, you are going to get C prime of C of S is going to be equal to. Now, before you integrate, you know that this one can come on top. Alright? Because of the power negative here, indices. So we are going to get Q of S, then integral of no more negative, but P of S dx. Then we break the last part, that is dx. We are going to name this equation 6. So name that part equation 6. So we have C of S to be equal to this. You see, you can't integrate this bunch of stuff, so leave it like that. Therefore, since we have the C of S, that is because of the C of S that we are looking for. That means us to taking the derivative of the whole of this and doing the substitution of this. So we are now bringing it back. Therefore, y of p. So by substitution, y of p is going to be equal to integral of p of s e raised to the power p of s dx and the whole of the dx. and that is multiplying e raised to the power negative p of s ds. So that is multiplying that. And we are going to end up getting y of p, that is for the particular solution, to be equal to e raised to the power integral of p of s ds. Let me bring it on top. Times the integral of and it's going to be equation 7. So therefore, this is the particular solution for the non-homogeneous equation. So we have that for the particular solution. And don't also forget that we also have that for the homogeneous parts. And that is y is equal to, and that is, since that is representing the homogeneous part, we bring subscript h, and that is equal to c e raised to 1 negative p of s ds. Very good. Now, for us to get the general solution, so for us to get the general solution, hope I can clean this part. For us to get the general solution for the non-homogeneous equation, and you know that the non-homogeneous equation is y ds plus p of s, y is equal to p of s. So for us to get the non-homogeneous equation, it's going to be y subscript h, that is for the homogeneous part, plus the particular solution to be equal to y in terms of x. So therefore, y in terms of x is going to be y subscript h plus y subscript p. Very good. Very good. And also, and so we are going to add this or this part to this side. So generally, we are going to get some bunch of steps. So since we have the yp here, then let me reduce my work. Plus, so y of x is going to be equal to c e raised to the power negative integral of p of x ds. So that's going to be plus that. Alright. So this becomes the general solution for the non-homogeneous part. So for you to get the general solution for the homogeneous part, it gets you finding this y of h, that is for the homogeneous part. And for the non-homogeneous part, or for the rest, or for the particular solution, let me say that. And for the particular solution, that will be from this side to this side. And that is y of p. So by combining it, then you get the general solution for the whole non-homogeneous equation. We'll be back to solve the example, and make sure you go through this one and understand it well, because you need it. It's the same process that we are going to go through when solving for the question. Thank you.